open up Onshape as usual. I believe there's a homework assignment to do one of the parts of the air engine. So if you have any questions about that, be prepared to ask them, since that's what we'll be starting off with.
Excuse me?
Yes.
I wasn't here last class, so where are we on Onshape?
Great question. I see we have more than one.
And also like, are we starting now, or are we just logging off?
For now, log on. I was looking for a place to sit for this class, so I don't have my slides up at this moment, but momentarily we will get started. So I'll post the slides for this week after the class ends. They're not on Classroom right now, but you can look along. So did anyone have any questions with the homework from last week? I'll do a quick recap of what we covered, since there were 2 students who were missing, but if you do have questions about the CAD, were you able to complete the homework successfully? That's also something I'd like to know. You can just type yes in the chat.
I didn't do any homework because, you know.
All right. Let's see. All right, let's get started. So for those of you who could not join us last week, we finished up the U-joint project. So everyone has that assembled and working, I hope.
Except for me.
So if you've not done it, I'd recommend doing it, since that was homework from 2 weeks ago. But,
yeah, I didn't, because, you know.
Great. So we did that, and then we also went over the space plate, which was the other assignment from 2 weeks ago. I think most people made an attempt at it. I'm not sure if someone did it, but by this point, hopefully you know enough about how to read drawings that you could make something like this. Another thing we talked about was how to download parts and import them into your own Onshape document. So later on, we'll have a part where you'll be able to download things, or you'll probably need to download things. So if you weren't there to see it, I'd recommend, I guess, if there's a video, watching that or recording. We also did the inverse, which is exporting a part from your document into like a normal file that you can send to other people. And the homework from that week was to go over, I believe, in class we made the cylinder together, and the homework assignment, I believe, was this piston. So all of these drawings, as I've said, are available on the Classroom, where I have previously posted all of the drawings, and the website where the drawings originated from. So this week, as I said before, we're starting off just taking questions. At this point, you have made the base from 2 weeks ago's homework. The cylinder we made together, and the piston was the homework assignment from last class. So you should have these parts. If you're not quite done with all of them, don't worry too much about it. We have a way to deal with that when we get to that bridge, but if you have any questions with the CAD, I'll go through them with you or debug them. All right, so the piston was easy enough, right challenging level. I explained you can just ignore the tolerances, so a fairly straightforward part. I'm not too surprised if you don't have any questions. So we'll get right on with it then. So this week we'll talk a bit more about what you see when you look in your CAD program. You may have heard me refer to these things before, and specifically we're going to look at how you might go about modifying a part, especially when if you're working on a group project, you might not be the only person who's working on this document, or you might be working with someone else's part document, and you may need to change it, maybe to fit the new design requirements or to accommodate something that you found to meet your own purposes. So another place where you might see this is when you're working on a model over a long period of time, maybe later on, you discover that something you did earlier on was not good, or there's a mistake and you need to go back and correct it. And so how do you do this? What you've probably seen before many times, I've referred to this as the feature tree. So this is, you can see the word features up here. And in this list is pretty much every operation that you've done in the document. So you can see that when I created this part that you see here, like I created a sketch, I extruded it, I did these fillets, I did more sketches, more extrusions. You can see basically a history of everything that I've done to create this final product that I have here. So this is what's called the feature tree, and you'll have this on every one of your parts. And one thing I'll show you is that the feature tree adds features in chronological order. So every time you add one, it gets added to the bottom. And this bar here, this little gray bar here, is called the rollback bar. What you can do is actually click and drag on this and move it up. So let's say move it up to here. It'll actually take you back, kind of back in history to when you only had these features. So before you created these features, now you're looking at the document at the state that it was when you had only made these features here. So what's really interesting here is now that I'm here, I can like create sketches. For example, I can create a sketch here, draw something. I'm not going to do it, but you can see that I can modify a part, and then when I'm done, I can bring the rollback bar back down, and it'll attempt to recreate all of these other features that I had before. So it's a very useful tool for modifying parts when maybe before I add these holes, for example, I needed to do something else, then I can go back, maybe add another boss here before going for this hole. It's kind of the usefulness of the rollback bar, which you might not have known existed, but think of it basically as taking yourself back in time before you did any of these things that are below it. And once you're done, you can go back to the present just by dragging that bar back down. So with that, that part that I just showed you, you should be able to modify it or like to open it up by clicking this link that I put in the chat. If you just click that, I believe I made the document public so that you should be able to edit your own copy. What you may need to do is create your own copy. So in my case, I see this, but it might not let you edit. If it doesn't let you edit, just go back to, I don't know, it should automatically create a copy, I believe. Hard to say, but if it doesn't, if you click on this link and it opens the workspace, but you're not able to edit it, all you have to do is go back here, right click on it, and where is it? Copy the workspace. Just hit OK. And for me, I already copied it, so I have a copy of a copy, but the copy you should be able to edit. So take a moment right now just to click on that link that's in the chat, open up this document, and get a version of this document that you're able to make changes to. If you have any trouble getting there, let me know. And if you are able to open up this document and you're able to edit it, then also please let me know in the chat, or I'll not know when to move on. Okay, so it seems like at least one person is able to do it. So That means it is possible to do it, which is always promising. Our objective today is going to be, or at least for this activity, is going to be an exercise in modifying a part. So let's say that you're working on one of your project teams, maybe for like a school project, you're trying to design a part. And let's say that you're working with someone else and someone else gives you basically what you have here, right? So from here, what you kind of see right now, I believe, is the part on the right. And your task is to essentially create the other one that you see here. So you have this version, sorry. You should have the version on the left with no holes and this kind of steep angle. And I want you to create this version that on the right that has these two holes in it and the angle is shallower. So given this part that you see here, and using what you know about how to create sketches and use tools like extrude, just take a few minutes to try to create this version on the right that has the two holes that go through the circular parts and modify it so that the angle is shallower. So you can see here that here the angle is pretty steep, right? You can see this angle here, and maybe you can't tell that well in this image, but here the angle is a lot shallower. So there are two changes you need to make, and I'll give you a few minutes to work on that.
Confused.
Yes.
I'm confused. Like I don't know. I did not get what I'm supposed to do.
Okay. Do you have a question?
Yes. Don't get what I'm supposed to do.
So the objective here is to take this part that I linked to you in the chat in the Zoom, and from that part, just maybe you have to create a copy, but make a copy that you're able to edit this document and then make the changes to this part so that it looks like this picture on the right, where there's two holes and the angle here is shallower than the one on the left. So hopefully that was more clear. If you have more questions, just ask.
Yeah, I'm still confused.
So what part of it do you want me to explain?
Can you like please say that? Because yeah, I'm not sure if I understand.
Right, so the end product is you should have a document here where the part looks like this on the right. And the way that you're going to do that is you're going to edit this part. So the same way that you would edit any parts that you've made, add some features or change some existing features in this feature tree. And by making those changes, you want to create this part.
I can't.
So if you're not able to edit the part, like I said, what you probably might need to do is go into your workspace, and you might need to create a copy of the workspace.
How do I create a copy again?
Let's see. In my case, since I'm the one who created the original document, I don't exactly see what you see, so I'm also
No,
not.
I mean like how? Can you just show me?
Let me see. So I'm guessing if you just go back to your workspace, it doesn't show you.
And like, how do I copy one?
If you go back to this page, are you able to see the workspace of this document, the mod demo?
Yeah.
You are?
I mean, what? Like, I do not see. I see the model copy on the. No, I don't.
Well, if you see something like this, you can just right click on it and click copy workspace. And the copy of the workspace, you should be able to edit.
Oh. Okay, I got it. And now I can edit it. Cool. It should be simple. Just
So I'll give you all just a couple more minutes, and then I'll ask someone, I'll just call on someone to explain what they tried to do. All right, so at this point, if you're able to do it, let me know in the chat, just say you got it. And if you do say that, I might call on you, ask you how you tried it. If no one says anything, I might just call on someone at random and ask them what they tried. Anybody? How about Owen? Could you tell us first what you tried to modify this part into the one with the holes and the shallow angle? All right, for the holes, you made a circle and extruded. It's very valid. That's what I did here, as you can see. Were you able to get the angle, or what did you try to change the angle of this? Didn't get to it, that's fine. Is there anyone who did get to it? Maybe Jason, did you make a try at changing this angle? That's also fine. I guess one call for volunteers, and then I'll just go through how you can do it. All right, so since it seems like may have been a bit tricky, I guess one thing that I would try is I would think to myself that I see this model and someone else gave this to me. I don't really know how it was created. So what can I do? Off the top of my head, there's not any basic feature that can just change an angle, like stretch it around like I could with my hands. So the first thing I want to kind of do is understand how this model was created. And the way I can do that is using this rollback bar, which I explained a moment ago. So we're looking at this part, and let's just roll it back in history. So I guess I should demonstrate on the version that you're looking at. I roll it back. So the last change was just rounding off the corners. Let's see, I roll it back again. I can see, oh, the next last thing that was done was creating this kind of bridge here. If I roll it back another feature, I can see, okay, so this person created those bosses, and I go back another feature, they rounded off these corners, and I go back another feature. So now I see the sketch, and here I kind of see how that angle was originally created. It was created as a sketch here, where this angle is probably defined somewhere in the sketch. So at this point, what I figured out is that the creation of this angled feature happened no later than this very first sketch. So I know I have to change this sketch in order to change that angle. So I go in here, I click on edit sketch as you do, and I can look at the sketch. And fortunately, the sketch has been defined in such a way that I can easily see like where the angle comes from. It's this dimension right here. So what I can do, and I'll go back to the other document. What I can do in this situation is go into the sketch, hit edit, and I can just change this angle. So you saw in the other version how it was 45 degrees. Maybe I can change this even further, maybe to 10 degrees. So now it's even shallower. And if I click OK, the sketch is OK. And let's roll it back to the present time, right, with all the features on it. You can see, because this part was designed fairly robustly, at least robustly enough to handle that changed angle, that the final result now has that changed angle. So kind of went back in time. At this point, I identified what sketch the change I want occurred in, or where that feature occurs in. I entered that sketch, and I can just go in and type whatever number I want. Maybe I'll go back to 45 degrees. I made sure that it works, and then I just rolled back to the latest feature and the model updates. So hopefully that all made sense. If you had any questions about that, let me know. But it's kind of an approach that you might use if you're greeted with this part that is pretty unfamiliar to you, but using the rollback bar, you can get a good idea, a good sense of how this thing was created chronologically. And that can let you make the appropriate changes as well. One thing that I'll say is that not every model is constructed in such a way that you can just change things like that. There's a lot of times, maybe with fillets especially, where if you make a big change early on in the feature tree, there's a good chance that it will just break things, or these features will refer to things that no longer exist, and then the whole model will kind of break. So in those cases, you have to individually go through each of the broken features, figure out what's wrong, fix it. So in this case, we got kind of lucky, but it worked out, and hopefully it taught you something useful. So that was our first activity. I didn't hear any questions, so we'll move right along. I'm now going to show you a few other tools that are very useful in terms of the Onshape environment. A lot of these tools are common to other CAD programs, so if you do use those, you'll probably be able to have an equivalent. And these are especially helpful if you're designing a part for a real project, maybe a school project or a team where you're trying to build, say, a robot. In those cases, you kind of need more information about the model that you might not just be able to get by looking at it. And the first thing I'll show you is material assignment. So let's see. I'll just work in this copy. When you create a model, the computer doesn't treat it like a physical object, right? It's just a bunch of geometry, and this geometry consists of basically an enclosed volume. But in terms of real life, there are no such ideal enclosed volumes that just exist abstractly in the real world. All objects in real life are made out of some kind of material, and that gives it properties such as weight or density, strength. All those come from the material. So if you want to understand, for example, how much your part weighs, then it needs to have some kind of material. So if you right click here in the bottom left corner on the part, you can right click that, and one of the options here is to assign the material. And if you do that, Onshape provides this material library. So for most purposes, you'll probably find something appropriate there. You can also do a custom material, but you probably don't really need that. And you can scroll around here, you can see there's a lot of options. PLA is the common 3D printing material. So that's probably one that you'll use if you use this feature at all. So let's say PLA, and it adds a density of PLA right there. So if I check on this, now Onshape will treat this. Oops. It'll treat it as PLA. So I can change it to something else as well. I don't know, PET. If I change it, I can click the check mark and it'll make the appropriate change. So what was the use of me doing that? That's where this next thing comes in, and that is the mass properties. And so mass is very important when you're designing something, especially for a real system like a robot, because there you care about a lot of things like, for example, the weight distribution, or just in general, how heavy this thing is. So at the bottom right corner here, you can see there are two symbols. On the left is a tape measure, and on the right is a beam balance. So if you click on the balance on the right, you can see mass properties. And the first thing it prompts you is for a part to measure. So I only have one part in this workspace. I'll click on part 1 here. And you can see right away that it pulls up all of these properties. So if you didn't assign a material, it won't know what the mass is because it's just thinking about this kind of abstract geometry. But once I assign a material, then it knows the density and it can calculate things like the mass. The volume is just geometric, likewise, surface area is geometric. But you can see how this might be useful. For example, where you might need to know how big it is, how much surface area it has. If, for example, maybe you're trying to paint this thing, how much paint you need, that's related to the surface area. And there's no need for you to calculate things like that by hand because you have this handy tool here that'll tell you these things. Other things like moments of inertia, that's useful if you're doing strength calculations. You have things like center of mass. It's useful for weight distribution. So these tools exist. Don't worry too much about when you'll use these, but just know that they do exist. So if you ever do need them, you kind of have that connection there. This third tool is called measure. And this is probably the most useful one. I believe we may have even shown this in the previous CAD class when we were trying to figure out how big things are, but we have this tape measure here. And if you click on it, it tells you to select entities to measure. And that pretty much means you can just click on things and it'll tell you details about its size and dimensions. So you can see that I clicked on a circle there, this highlighted orange circle with the measure tool. And what things are there to know about a circle? There's the diameter, there's a position of the center with respect to the origin. So in this model, the origin is located over here. And so the center of the circle is located at the coordinates 1, 0, 1.5. So you probably learned this in math class, how you have like 3-dimensional coordinates that tell you where everything in space is located. That's kind of how this works. And it also tells me the circumference, the length of this arc that I selected, or this closed loop that I selected. So if you're familiar with geometry, you know that the diameter or the circumference of a 1-inch diameter circle is going to be pi inches, and that's 3.14, etc. What else can the measure tool do? It's very versatile. For example, if I want to know the length of a line, I can just click on the line. This line is 3 inches long, plus some change. I can also click on surfaces like this. It'll tell me some other features. This is a circular surface, so it tells me the diameter of this cylindrical circle cross section. It tells me the area of this, and it tells me the radius. So pretty standard. Now, what if I want to know something like the center to center distance between these circles, right? Maybe I'm designing another part where I have to align some pegs to go into these holes. There's no line that just connects the center of the circle to the center of the circle. But what I can do here is I can click on the circle, and then without clicking the background, I click on this circle. And now Onshape does even more things. It tells me the center distance. So if I hover over here, it shows you that black line. That's what it's measuring, the distance between the circles. It also tells you kind of how that distance is divided into
Leo,
components.
there's anyone outside.
Tells you how that distance is kind of divided into components. So the center distance is kind of like a diagonal line, but maybe you're just interested in the horizontal distance. Then you're interested in this x distance, which is 5 inches. Maybe you're interested in the z offset, so how the height difference between the circles, that's minus 2.207 inches. There's also the minimum distance, which is the closest distance between those features, and et cetera, et cetera. So you can see if you ever need to know something about this part, especially since last week we talked about how you can import parts that other people made, things from websites like Thingiverse or from parts catalogs. And for those, you might not even have access to these features, right? You might not have access to the sketches and the extrusions and whatnot. And in those cases, it's very important to have a measure tool so that you can design your own things to match up to the dimensions of whatever you got. And the last thing here is called interference detection. And this is useful for assemblies specifically. So a lot of the reason that we create assemblies in CAD is to make sure that this thing that we're trying to build in real life can actually be built and that it moves the way that you expect it to. For example, if we're trying to build that ellipse trammel in real life, we'd want to make sure all the parts fit together and that the handle will be able to move correctly. Same with the U-joint. You'd want to make sure that the things can actually turn and they won't bind or get stuck. And the CAD helps you do that. But one thing that might not be completely obvious just by looking at an assembly is whether or not different parts are completely clear of each other. In other words, it's possible that you design things where the parts are actually going through each other or occupying the same space, but
Excuse me.
yes.
What does Onshape do if like your parts are overlapping? What would Onshape? What does Onshape do if I have overlapping parts?
Yeah, so that's a good question. That's kind of what the interference tool does. Onshape doesn't actually care if you create an assembly and the parts go through each other.
Okay.
You've probably seen this before when you're trying to insert parts or like fasten parts together. You remember how sometimes like the parts would just come in upside down and then they'd just be going through each other. So Onshape will let that happen. And if you don't catch things like that, you might make a mistake in your assembly where, you have something that's not physically possible. Let me see if I have an assembly to demonstrate this with. How about our do nothing machine? So consider our handle here, right? Let's say that for some reason I accidentally put the handle on backwards like this, and you can clearly see here that these parts are intersecting each other. If I click on this, you can see the outline that kind of goes through the link. So this is not good because in real life, you can't just stick the handle through the link and have them occupy the same space. But just at a glance, casually looking at something like this, I might not catch that. So what can I do in this situation if I'm trying to verify my assemblies to make sure they're good? I believe here on the right, underneath your navigation cube, you have this other cube with a drop-down menu. And if you scroll down here to the bottom, there is a tool called interference detection. So if you click on that, it prompts you for instances to analyze. So let's say that in this case, it's pretty obvious where the interference might be, but I select these two parts, the link and the handle, and Onshape detects that these parts are intersecting each other, that they're interfering with each other, and it highlights it in red. So now it's pretty obvious to me that these parts are going through each other. And you might say that that's such an obvious example, or like, why would I use this tool to tell me that? But in a lot of cases, it's not entirely clear whether or not you have a clearance because it's a lot more subtle than this, right? You might have an assembly here, maybe you're concerned that this trapezoid is slightly too big and it's just barely clipping into this wall. Even if it's a very small amount that it's just clipping into the wall, it's still not good for making things in real life because you want things to, have some, depending on the application, you might want some clearance between the parts. So when it's not obvious, you might just want to use the interference detection tool to make sure that your assemblies are okay. For example, if I click this and this, it tells me no interferences. So these things are not interfering with each other. They occupy different space. So I'm all good on that front, as opposed to this and this, where, oh, I do have an interference here. So those are the tools. There's a bunch of other evaluation tools in Onshape and even more in other CAD programs, but hopefully this is a good batch to get you started. Don't worry too much about, oh, I have to use these right away. Just when the time comes and you need to do something like measure things, you'll know that the tools exist and you can just look up like, oh, Onshape, how do I measure the mass of my part? You know now that most CAD programs will have a way to do that. So that was kind of the me talking part of this class. Now we're gonna resume working on this air engine project. So I know a lot of you, or at least two of you, missed a class, so you might not be completely caught up on all the parts. That's fine. The main thing that we covered last week that was new is the whole tool. So I'd recommend looking at that class just to know how to use the whole tool. But in reality, like for our purposes, you don't really need the whole tool since we're not going to machine this in real life. You can extrude a circle or like extrude cut a circle and it's functionally more or less equivalent. But I think I will actually go through the whole tool today as I'll demonstrate the crank wheel, which is a part that we didn't quite get to last class. And we'll make this together. So I want you to open up the document that you used when you were making the base plate or the piston. So I want you to have basically all of your air engine parts in the same like document as different part studios. So if this is your very first part that you're making for the air engine, just make a new document and put all the future parts in there. If you've been doing the homeworks, you probably have a document already. Just open that up and we'll create our crank wheel. Create part studio, blah, blah, crank wheel. It's a good idea to name your part studios. And we're off to the races. So let's take a look at this drawing. As always, I'm going to ask you the question, what shapes do you see and what feature tools are you going to use? Feel free to answer. I do want to hear an answer before I continue. Christopher, how about you? What shapes do you see and what features would you use to make this thing?
This is a rectangle.
Rectangle.
Yeah, on the right drawing. I think that's
Okay, yeah, I see rectangles here.
Yeah.
And so what features do you think we'll use here?
I think it's a rectangle tool.
Okay,
To use that.
sure, yeah, you can use that. What, in terms of features, in terms of the 3D aspect of it, how would you make this thing?
Just make it a box. Make like a box. So it's a rectangular prism.
Yeah, sure. So I agree with the part where you can use like rectangle tools or line tools to make your sketch. But in terms of interpreting this drawing here, let me blow it up a bit in case it's a bit small. It's not quite a rectangular prism. It is a prism of a kind, but it happens to be a circular prism or a cylinder, as some might call it. So again, that's just a matter of getting experience with how to read these drawings. I know when you're first working with them, it's not the most obvious how to convert these shapes into 3D objects in your mind, but on the left image, you can kind of see you have these concentric circles. And when you look at it from the side, you can see the rectangles. So that tells you that essentially they're cylinders. Hopefully that's clear, but if it's not, as we go through the CAD, it'll probably become more clear. But I do like the idea of using like rectangles or rectangle-like shapes. And that's because, like I said in the past, when we talked about the revolve tool, when you have this kind of tiered cake structure, you kind of want to use a revolve rather than multiple extrusions just because it'll keep your things cleaner. So with that, let's get started. The first thing I'm going to do is create the basic shape of this, which is going to be a kind of tiered cake. And to do that, I'm going to create one of these half profiles when you cross-section it. So it's kind of going to be like an L shape or a staircase shape. So let's try that. Create my sketch on one of the planes. I chose the front plane, but as you probably know, it doesn't matter. And the general shape I want is some kind of L or angle block, right angle block shape. And you'll notice that as I drew my lines, I was careful to make sure all of these constraints were kind of built into it. So these lines are all automatically perpendicular and vertical and horizontal. And so there's already a bunch of constraints in here that I get for free just because I was careful with how I drew my lines. So you don't have to do that, but it'll save you some trouble. So I see that shape. Hopefully you see where I'm getting this shape from. It's kind of this L shape here. And now the next question, of course, how big do I make things? We look at the drawing and we see all the dimensions there. So let's start with 0.461. That's kind of the distance from here to here. So the way I'm going to do this, I'm going to kind of treat it like it's sideways. So in my on shape, I'm going to be kind of modeling it like this. But the dimensions are going to be the same. So 0.461, that's kind of the height of my cake. So from here to here, the height of my cake, I can also just dimension this line is going to be 0.461. Let me just move that over here. So that's good. And then the height of this bottom part, this thin disk here, the height of that is 0.211. So again, this time you probably need to dimension it like this, where you have, actually you can just dimension this line segment here. So this one should be 0.211. So that's a good portion of this part done. We still have blue lines, so let's drag them around to see what degrees of freedom we have left. So basically the horizontal distance, basically the length of this line and the length of this line are left to be dimensioned. And I can do that as soon as I find out what the dimensions are. So I'll rotate it back so I can read the text. In this case, we have to do a tiny bit of math, as it doesn't quite tell us the distance from like this center axis to the end here, but it does tell us the diameter of the circle that we're eventually going to get. So from here, from the axis here to the end of the thin disk, we have a diameter of 1.187. So we divide that by 2 to get the distance from here to here. So 1.187 divided by 2. So to dimension this line here, again, the number is 1.187, and I'll divide it by 2. So you can actually just put like operations where you ask for dimensions, you just type in 1.187 / for division, and then the number 2, divide by 2. Pretty straightforward, hopefully. Feel free to ask if it's not. And there you go. So yes, I heard an
It was me umming.
All right, yeah, that happens. I all the time as well. So the other dimension is the diameter of this thinner, like second layer of the cake, this stubby disc. The diameter of that, if we look at the drawing, is 0.5. So we know that the radius, the distance from this axis to the end of that, like thinner disc.
You're going too fast because I can barely keep up.
All right, thanks for the feedback. I do appreciate it because it's hard for me to have a sense of that kind of thing. Hopefully, looking at this drawing, like you know how to dimension these lines. I'll leave this up for a few seconds, but dimension of this is 0.5 divided by 2. And again, just to recap what we're doing and to let you guys catch up, we're trying to create this kind of L shape, or this, I guess, block with the corner cut out shape. And where we're going to go from here is we're going to revolve this sketch like we've done before for like handles on parts. And when we revolve it, the shape is going to essentially create two cylinders that are stacked on top of each other, which is the basic shape of what the final part is going to look like. The main new thing that you learned from watching me do this is that you can put math operations for dimensions. So 0.5 divided by 2, you can see that I typed this in for this dimension, and if I press enter, it's able to do the math and put in 0.25. So I'll leave this up for a second. I do realize I may have been going a bit fast. I guess I'm in a bit of a busy state of mind recently, but it's good to take things slow as well. In terms of sketching though, these are all things that you've seen before and have plenty of practice with. So don't be too overwhelmed. Not much is new here. I'll accept the sketch, and as you know, we get our sketch profile. Should look something like that. Hopefully you're all able to get the dimensions. And this time the dimensions aren't on Classroom, so you don't actually have access to the slides, but if you do want the drawings, those are on Classroom right now. So you can pull up the PDF and like have it side by side with your like split screen, like have the PDF on one side, have the Onshape on the other side. So you do have this drawing in that PDF. And I will post these slides after the class. So like I said, our next step here is to use the revolve tool. So you've also used this before to make the handles on the ellipse trammel and the sprocket assembly that we made. And revolve tool hopefully is familiar to you. You open it up, solid, new. You want to select a sketch region as the thing you just sketched, and the revolve axis will be this vertical line here at the center. And if you click that, in the preview, you can see this is what the final shape should look like. You have kind of our tiered cake here, the two cylinders stacked on top of each other. And I'll accept it for now. And in the drawing now, if you were confused about the drawing before, which is totally understandable, you can see that if you look at the top of this shape, it's going to look like two concentric circles. So it's a circle and a circle. And that's what you see on the left here, a circle and a circle. And when you look at it from a side view, you're going to see two rectangles. So if I go to right view, you can see, oh, there's a rectangle here and there's a rectangle here. This is kind of what we were seeing in the drawing. So at this point, with this shape in our workspace, all we have left is to drill a few holes, right? So looking at this drawing, looking at the dashed lines that you can see that there are 3 holes. There is one big one that goes straight through the center of the part. There's a small one that goes kind of here towards the top of the part. And there's another one here, the third one, that kind of goes on a different axis. It kind of goes sideways into this cylinder. So we're going to create these 3 holes now. So let's get right to it. I'll demonstrate the hole tool. For those of you who missed last class, this is the main new thing that we learned last week, other than like the whole importing and exporting parts, but I'm sure you'll be able to catch up to that as well. So we'll start off with a simple example. We'll drill the hole that goes straight through the center here. Looking at the drawing, the diameter of that is 0.25 inches. It's a quarter of an inch. And looking at the side view, I can see that it just goes entirely through the whole part. So this is your hole tool. It's located kind of in the middle next to the pattern tool. So one to the left of that is your hole tool. You click on it, it opens this up, and there's a lot here. Don't be intimidated. For the most part, you don't need these. I need to charge my computer. But that
So
can-
what do I do again? Because I'm confused.
so are you able to create these? Do you have this right now?
No, I don't. Can you like show me again?
Yeah, so we're able to create this sketch here.
Yes.
So
But like I don't know how long. What's the distance of the line that separates the top from the bottom?
sorry, I need to move myself to charge my computer, but here you go. I'll bring up the sketch for a second.
Oh, okay, I have it. No.
Right, so
Now,
yeah.
now what do?
The next thing you want is to revolve that as you did for the handle back in
Well, how
CAD
do I revolve?
course 1. So your revolve tool is the second one over. It's next to the extrude tool. And if I edit
No,
this,
but like, what do I revolve? Like how? I clicked it, but like how do I revolve?
right? So the revolve tool asks you for 2 parameters. Basically, the first one is a face or a sketch region. So the thing that we just sketched, this shape, that's your sketch region. And the second thing is a revolve axis. That's the line about which you're rotating that sketched profile to create your 3D part. So in our case, our revolve axis is this vertical line here. If you just click those 2 things, hopefully this is what you see. And you can hit the green check mark and get the 3D shape. So I guess, again, we're kind of running towards the end of the class. So I'll show you how to do the whole tool. There's probably a good chance that we won't actually finish the part, but I'll show you enough about how to use the whole tool. So even if you weren't here, you'll be able to finish this part. So whole tool right here in the middle. There's a lot of things here, but don't be too intimidated. For the most part, you don't need most of them. In our case, we'll always use a simple hole. Counterbore and countersink are used to create like the little divots or the indentations at the end of the hole or at the opening of the hole. And that's for using hardware like screws or bolts. But since we're just making a model, like we're not going to build this thing in real life, we don't have to worry about that. Next, we have essentially have 2 options here, through and blind. So through means you go through the entire part. Blind means the hole will stop at some point. So it doesn't go through the entire part. Essentially, blind just means not through, and through means it goes all the way through. So in this case, we have a hole that goes all the way through. So you're going to use the through option. Next is the standard. For this project, we're only going to use custom and ANSI. In this case, we'll use custom, but I'll also show you ANSI just so you know what it does. Custom is easier though, because all you have to do is specify a diameter. So in this little icon here, you can see that it's indicating the diameter distance. So from there, we know that the diameter is 0.25 from the drawing. And then the next thing is a sketch point. So I had assumed that you can just use the origin as a point, but turns out you can't. So we'll backtrack for a second here. In order to create a hole using the hole tool, apparently you need to use a sketch. So we'll create a sketch. I want to sketch on this knob here. So I'll click on this face. You've seen me do this before, where I sketch on a face of a part. So I'm sketching right here on this. And we have our point tool here, kind of again, like the 6th one over, next to the spline tool and the text tool. We have the point tool. So I can click anywhere on here, but I'll just look down on here and I'll click on the origin. I'll click on this center here, right on the center. And that'll create my point, hopefully. Yeah, you can see that I created my point. And that's the only thing I need in my sketch, just a single point. I'll confirm the sketch, and I have my sketch with a point in it. So sorry if I go through this a bit fast, but we're almost out of time, so you can watch the recording if you need to slower tutorial. I also went through this somewhat deeply last class, so you can also watch that. We have our hole tool. Again, simple, blind, or simple through, custom, and the diameter is 0.25. And now I select this vertex. So on this sketch vertex, on this point, that is where the hole will be drilled essentially. And the merge scope is just part 1. That'll probably happen by default. And if I do that, the hole tool allowed me to create a hole in my part. So I didn't have to CAD a circle, I didn't have to sketch a circle, I didn't have to extrude anything. I just used the single hole tool and I used a point that I sketched in this sketch, and that let me create a hole. Now you might be wondering, if you weren't here last week at least, you might be wondering, oh, what do all these numbers mean? What does 6-32 thread mean? That is the other option that is not the custom hole. So custom is for when you want to specify the diameter yourself. ANSI is for when you're using hardware. So if you go to the hardware store and you buy screws or bolts or whatever, it's going to be to some kind of standard. And if you're in America, it's probably going to be ANSI. So in terms of this, don't worry about, I'll just tell you what to do. You want to click tapped. If there are 2 numbers, if there's a number dash another number, you want to click tapped. Size is 6, threads per inch is 32, and that's where 6-32 comes from. You have number 6-32. This percent doesn't matter for you at all. Don't worry about it. And this diameter is filled in automatically based on the ANSI standard. So it seems pretty overwhelming since there's a lot of things to do, but you just need to copy this exactly. Or if you can't figure it out, just like, it doesn't really matter what the hole diameters are, you can make something up for the homeworks. But hopefully it's pretty straightforward. You just pick your standard ANSI. If there are 2 numbers, like number dash number, you click tapped. Number 6-32, that's where 6-32 comes from. You don't have to touch this, you don't have to touch this, you don't have to touch this. It's the same process, and you click check mark and it creates the correct hole that is marked by this drawing. So that brings us to the end of the class, but hopefully you can imagine how you create the rest of this crank wheel. Depending on the course schedule, I might finish this demonstration next week, or we might just go to the assembly. So for the homework for next class, I do want to give you more of a challenge since you've had some experience. You've had like 2 homework assignments already, or 3 if you include the U-joint in terms of reading drawings. So this next one will be like a much bigger challenge in terms of reading a drawing and creating a model from a drawing. You can see like a preview what these drawings look like. They're also on the classroom in the PDF. So you can see like the bigger version, the full version of the image. So these are called the flywheel and the upright. They're labeled in the bottom right corner, flywheel, upright. So just pick one, try to model it as best you can. There's a lot of dimensions, but if you're smart about the way you do it, it's not too difficult of a part. So just try to do one. If you're really ambitious, try to do 2. But CAD one of the parts for homework. When we come back next week, I'll either continue to finish like the part demonstrations, or we'll start on the assembly. And if you don't have all the parts CADed because you missed a class, don't worry too much about it, because we'll figure some way to let you do the assembly regardless. So in any case, the main lesson is do this, do one of these 2, and I'll see you again next week, same time, 4:30 on Friday. That concludes the class. If you have any last minute questions, feel free to ask, but bye-bye.
Goodbye.